All right, accentuate the negative. So we were talking about algorithms for adding, subtracting, dividing, multiplying negative numbers. So before we begin, let's deal with some basic ones. Multiplying and dividing are probably the easiest two operations. So let's talk about that first. So the algorithm for that is a positive times a positive is a positive. And that's the one that you've been dealing with ever since second grade. A positive times a negative is equal to a negative. Likewise, a negative times a positive is equal to a negative. And then the really counterintuitive one, a negative times a negative is equal to a positive. So in essence, if you multiply two numbers together and the numbers are the same, your product will be positive. If you multiply two numbers together and they have opposite signs, your product will be negative. Now, adding and subtracting is a little different. We did come up with some algorithms that I realize that you probably have already forgotten. But in essence, here's what we need to realize. We have a number line here where negative numbers are on the left and positive numbers are on the right. And so subtraction is essentially moving in that direction, and addition, or positives, are moving in the right. So when we take a look at this problem, 30 minus negative 17, what's that saying? What that is saying is we're starting at 30, and then we're going to do the opposite of subtracting 17. So the opposite of subtracting 17 is, in fact, adding 17. So we end up with 30 plus 17, which is equal to 47. So the algorithm that subtracting a negative is the same as adding a positive will still hold firm. Now, if we start at negative 17 and we do the opposite, or subtracting 30, well, negative 30, I'm sorry, that means we're starting at negative 17, which is way over here somewhere. Come on. So let's say negative 17 is here on our number line. We're going to do the opposite of going 30 in the negative direction, which means we're going to head this way. Adding and subtracting a negative is the same as adding a positive. So really, we're going to end up with negative 17 plus 30. Well, that's just the same as saying 30 minus 17, because the order of addition problems doesn't matter. And 30 minus 17 would give you 13. So if we start at negative 150 and we add 75, move 75 in the positive direction, we'll still be in the negatives because we didn't get to 0 yet. We're going to end at negative 75. If we start at 15 and we take 27 away, that means I have 15 to get back to my 0. So I head back to my 0 point, and that's going to take 15. Well, how much do I have left over? I have 12 more to take away. So I'll end up with negative 12. So if I start at negative 14 and I add negative 15, that means I'm going to add in the negative direction. I'm going to go to the left. So therefore, negative 14 plus negative 15 is going to be negative 29. Oh, fractions, I'll have fractions. But the rules don't change with fractions. You need to have a common denominator, so I still have my 3 over 4 plus negative. And we're going to have, we need fourths, so we have 2 fourths. So this is all equal to just 1/4. That's it. So Robert wrote this wonderful expression. What is the answer that Robert found? Well, another banned DPS phrase is, please excuse my dear Aunt Sally. I'm going to use it anyways. Please excuse my dear Aunt Sally. And the reason why we don't like it a lot is because multiplication and division have an equal value, so you go left to right at this point. And the same for addition and subtraction. They are of equal value, so at that point, when you only have addition and subtraction, you go from left to right. That is the trick. So let's take a look at this problem. Do we have parentheses? You bet we do. So we have negative 1 plus 8. So I start at -1, I add 8 in the positive direction, and I'll get to 7. And so now I'll rewrite everything else that I've not done yet. So we have 9 times -6 minus 7. Well, I don't have any exponents, so I go on to multiplication. I have to do the multiplication next. 9 times -6 is -54. Minus the 7, because I rewrite what I haven't used. And so then -54 minus 7 is going to be a grand total of -61. Write 2 subtraction sentences to complete the fact family. Well, the thing is, we really want the n to be by itself. Really, since you know what's to come, we're going to have to be solving equations. So really, we want the n by itself one side of the equals sign. So we know that -8 plus 70 is going to be, right? So we need this to be 70, right? So we're only allowed to use -8 and 62. So I could say 62 minus -8, right? Or what else could I use? Well, let's do this. We could say 62 minus n is going to equal -8. That would also work. Let's leave it at that. Use one of the fact family sentences to find the value of n. So 62 minus -8 is going to equal n. Well, this subtracting a negative is the same as adding a positive, so we get 70 is equal to n. All right, please find the products and quotients. We're going to use our algorithms again. If the signs are the same, it'll be positive. If the signs are different, it'll be negative. So in question A, the signs are different, so it's going to be negative. 7 times 13, well, that's going to be 1, carry the 2, 91, right? Because 7, yeah. B, signs are the same, so it'll be positive. 8 times 2 is 16 with the 0 at the end. The signs are different, so it's going to be negative, and that goes in 33 times. The fraction bar just means division. Since the signs are the same, it'll be a positive, and 12 goes into 36 3 times. Anything divided by 0 divided by anything is just 0. And then when you multiply the fractions, just multiply the numerators, multiply the denominators. 1 times -5 is -5. 3 times 7 is 21. And that's it. Not too bad. And finally, I feel like we haven't done any thermometer questions. Maybe we can get a thermometer question here. Oh, good, no thermometer questions. Malik wants to take 4 of his friends to a movie. She knows it is $5.50 for a ticket and $3.25 for popcorn. What will it cost if she pays for the movie and popcorn for all 5 people? So we know that we have 5 people, and each person is going to require a ticket and popcorn. And so there we have. Equals the cost. So, oh, that's my number sentence. So, but it's good to have a number sentence to go with it. So I would do what's inside the parentheses first. So we have 5 people, and each person is going to cost $8.75. And so, well, just take out a calculator. 8.75 times 5, so that's $43.75. Now the next question is really asking us to have distributed this 5. So 55, or 5.5 times 5 is 27 $16.25. The $5 distributed to the $3.25 is $16.25, and you add that with your original $27.50, and look at that, you get the same answer. All right. So, all right. So we know that switching the order of addition does not change the problem. Switching the order when you have a subtraction problem, however, you know what? That is not going to be the same. Again, multiplication, you can switch the order, so it's equal. Division, not so much. So that's the commutative property of addition and multiplication. Again, there's no commutative property of subtraction or division. So finally, plotting the points. All right, so let's do run and jump. Do your x, y value first, and all coordinates are written as x comma y. So 1 comma negative 5, go over 1, down 5, 1, 2, 3, 4, 5. So there's A. B is 2 over 2 up 0. C is 3 on the x, negative 3 on the x, and 5 on the y. 0 over and negative 2 down. So that would be D. E is going to be negative 2 comma negative 2. So negative 2, negative 2. And finally, negative 3, 5. Oh, I've already done that. That's C. Perfect. And so there I have it. I've located all the points on the grid.